My name is Randy Brown, and I'm here to educate people on the value of fuel cells and if no fuel cells are available today.
So Randy's the equity portfolio manager for SoCalGas. I expressed that to y'all already. He's managed the hydrogen and fuel cell R&D initiatives there for SoCalGas for nearly 20 years. Now, fuel cells have been around. I think the first patent for them was 1803 or something like that. But you weren't around that long. But well done being there for almost 20 years working on this space. You're in a capacity that's either funded or co-funded a variety of fuel cell demonstrations in the commercial, industrial, and residential applications. I also have learned about you that you represent the gas company in numerous professional organizations, including, but not limited to, I want to be clear about that, the National Fuel Cell Research Center, the California Stationary Fuel Cell Collaborative, which I believe is here in the exhibit hall. If you haven't popped by there, please do. Clearidge Power is also a member of that. The California Hydrogen Business Council, among many others. And then you also manage a small equity portfolio for the company that's made 2 investments in fuel cell development manufacturers. And then you also had been in the Navy, for which I thank you for serving for the U.S. And that you have a BS in Mechanical Engineering at University of New Mexico. So Randy, your bio precedes you, as you just saw. So thank you so much for sharing your information. Now today, if I'm not mistaken, we talked about this, you're going to be discussing the investment that SoCalGas has made in fuel cells and kind of what that interest and that involvement has helped the market to materialize.
That's correct.
Thank you so much.
Can you hear me? Okay, but one comment on Andrew's presentation. As a result of the loading order he mentioned, California has the lowest per capita energy use in the country. So it's been a rough go for some of the California citizens, but it's paid off. As Nicole said, I'm Randy Brown, and I was the Technology Development Group at Southern California Gas. I have 2 hats. One, I manage a portfolio for small investments, and the second, I'm the company's hydrogen and fuel cell manager for RD&D projects. If I get this to work. Okay. I'm going to give a commercial for the gas company, as we all want PG&E. SoCalGas is a regulated subsidiary of Sempra Energy. Sempra Energy is located in San Diego, and it's also the parent company for San Diego Gas and Electric. We're the nation's largest gas utility. We serve almost 20 million customers with 5.8 million meters. Our service territory is about 20,000 square miles, and it runs basically from Visalia south to the Mexican border with a cutout for SDG&E, and we currently have a little under 10,000 employees. Okay, my talk was going to center on fuel cells only, and I was remiss in my presentation. I'm assuming that people know what a fuel cell is. Is anybody that doesn't know what it is? Right? Okay. Well, as Nicole mentioned, fuel cells were invented a long time ago. It was actually 1839. But we've been involved about 40 years of doing significant research and demonstration at an investment of over $20 million. I can't quite see the screen, so I'm going to look at this. In the 1970s, we were involved in funding basic research into cell stack, and reformer technologies. In the 1980s, we co-funded demonstrations at 12.5 kilowatts and 40 kilowatts, and these were phosphoric acid machines. In the 1990s, we purchased 10 200 kilowatt phosphoric acid machines and installed them at various customer sites in our service territory, such as hospitals and hotels and universities. We even put one in the Santa Barbara jail. These machines ran exceptionally well, but they were a little bit ahead of their time. They had 40,000 hour stack life projections, and every one of them exceeded that. We had one machine that even ran for almost 10,000 hours without a shutdown. And these were big numbers 20 years ago. But we didn't pursue this because we didn't really see a business opportunity at the time because A, they were too expensive, and B, nobody knew what they were. So it was a struggle with every machine to get permitted and to get the acceptance of the site managers and the engineers. So it took so long to do those things that it's fine for demonstrations, but there was no business there. Now we are involved in several projects. First one is we're demonstrating 6 PEM, that's proton exchange membrane fuel cells. in our service territory, 3 at residences and 3 at a commercial facility. We're involved in 2 300 kilowatt, and that's the biggest machine available right now, demonstrations, and they're both very exciting. The first one is at the Orange County Sanitation District wastewater treatment plant. This machine is up and running on natural gas, and it will soon be running on digester gas. And this machine is unique in that it makes more hydrogen than it needs. So we're using that excess hydrogen to store and use it in a service station to power hydrogen-powered vehicles. So this is a very unique application. The second one, we have not started construction on yet, but this is a project at the University of California, Irvine, and the same 300 kilowatt fuel cell, only in this case, we're using the waste heat from the fuel cell to power an absorption chiller. This is also a very unique application, which is very exciting for the gas company. We're going to be demonstrating another 5 kilowatt PEM unit from a different manufacturer at our Energy Resource Center in Downey, California. And we are currently demonstrating a very small solid oxide fuel cell at our Engineering Analysis Center in Pico Rivera, California. Andrew covered pretty much the investment tax credit and the SGIP, so I think I'll skip on this one. This is a summary of our SGIP activities over the last 10 years. I won't go through the whole thing, but you can see we've spent almost $85 million to generate 90 megawatts of power, and fuel cells is a small part of that, about $20 million and about 5 megawatts of power. I'm going to just give you 2 real-world projects. This first one is Gill's Onions, and Gill's is located in Oxnard, California, and they're the nation's largest onion processor. They're very progressive. They are very high in energy efficiency, but they had a couple of problems. They wanted to generate more power, green power on site, and B, they generate up to 300,000 pounds a day of waste products from these onions. And what they were doing was basically putting them in a truck, going to a field, composting. So there's insurance issues, there's liability issues, there's carbon footprint issues, there's the cost of trucking, so this was a big problem. So as a solution, they thought, why don't we just use this waste to generate biofuels? And then we can use the biofuels to power a generator. It could be a gas generator, a turbine, an IC engine, or a boiler. Well, they started on this track, and then they discovered fuel cells. Well, now you've got a new problem. How do you take this fuel, this biofuel, and feed it into a fuel cell? So they worked with us, they worked with manufacturers and the Gas Technology Institute, and they came up with a system that's actually installed and works. And you take the onion waste, you ferment it, you get biofuel from that, then you reform that biofuel to hydrogen, and the hydrogen goes into the fuel cell. So this project is up and running. The total cost was almost $11 million, of which SGIP paid $2.7 million. They got a $500,000 grant from the California Energy Commission, $3.2 million in recovery funds, and $1.8 million in investment tax credit. They're hoping for a 5 to 6 year payback. They installed 2 300 kilowatt fuel cells, so they have 600 kilowatts, which provides 100% of the base load requirement for the facility. And they estimate their immediate savings in energy and avoided hauling costs of over $1 million a year. So this is a great project, ideal use of the fuel cells to solve more than one problem. So we were very happy with this one. The second is a much smaller project. This is a home in the Coachella Valley, and it's the home of Jackie Autry, and Jackie Autry is the widow of Gene Autry. And for those of you too young to know, he was a singing cowboy back in the 50s, and an incredibly successful businessman. In fact, they used to own the California Angels.
And Mark Hopkins Hotel in San Francisco.
So she wanted some fuel cells, so we installed 2 5 kilowatt fuel cells. And fuel cells generate waste heat, and they're using this heat to heat her swimming pool with. Total project cost about $94,000, of which SGIP was $25,000. She says that her electrical bill was reduced by 40%, which tells you some idea of the size of her house. And it has a 3.2 year payback. So this is a much smaller project than Gill's, much smaller units, but a very attractive payback. So I guess the takeaway from this is fuel cells do work, they do solve real world problems, they're commercially available, and it also says that incentives work. So we have been very happy with this program and hope to expand it in the future. So thank you.